Today we are going to continue with our chapter integrals. Today we are going to do methods of integration. Methods of integration. Alright, earlier we did the rules of integration, what is integration, formulae which we are going to use in integration, and some basic questions, the properties. Now today we are going to start with methods of integration. We have three methods of integration, that is integration by substitution, integration by partial fractions, and integration by parts. Alright, integration by substitution, integration by partial fractions, and integration by parts. The most important, you say the base of all the methods, though all the methods are important, but the base of all the methods is the method of substitution. Very, very important. Almost all the questions we use method of substitution. Now let's see what do we do. By name it is clear, substitution means we are going to substitute something. We are going to substitute something. It means if the integral is given to me, f of x dx, I hope you all remember the basic forms. F, the function is called integrand. X is independent variable with respect to which we are integrating the function. We can transform this integral into some other variable. We can transform the form of this integral by changing into some other variable, transforming the form जिसको हम लोग integrate कर सकें. Is it clear? The purpose is transform the form of this integral so that we can integrate the resulting function. What do? We put the independent variable is equals to function of t. Alright. Differentiate with respect to t. Whatever the variable we have used, with respect to that variable we have to differentiate. So it becomes dx upon dt, g dash t. So dx is equals to g dash t dt. Is it clear? So now my function has become f of g of t into the value of dx is g dash t dt. Now students, keep in mind which function to be substituted. See, you will not get a single function in the integration, no? So your target is, very wisely you have to choose which function to be substituted. Is it clear? Preferably, always we substitute that function whose differentiation is given along. Whose differentiation is given along. Alright? Because if differentiation is given along, the question becomes easier. The substitution becomes successful. So target is wisely, first of all I have to think what to be substituted. My target, try to substitute that function whose differentiation is given to along. And as I told you, it is very, very important topic. So you have to do it properly. It's a base of integration. Let's do some questions related to integral, this method of substitution. Now see, my first question is sine mx dx. Sine mx dx. I told you our target is to substitute that particular thing whose differentiation is given to me. Is it clear? Alright. So that such kind of substitution, so that my question becomes easier and I am able to write the answer of it. Alright, now sine's differentiation is cos, which I don't have. But if I talk about mx, what is the differentiation of mx? Differentiation of mx is m. Differentiation of mx is m. You all know how to differentiate a function. Differentiation of mx is m. So now it is m, which is a constant and does not matter. And you have done a property. If I have a constant, that constant goes out of the integral. So constant does not affect the question. So what I'm going to substitute, mx is equals to the other variable. Alright. Now what do? We differentiate both sides with respect to the variable which is given to me. So m coefficient remains as it is. X ka differentiation would be dx upon dt. T's differentiation is 1. So m dx is equals to dt. Now with dx in the question I do not have m. So what I will do, I will take this m on that side. Is it clear? Constant do not matter. I can take a constant that side, but you have to be careful when variable is there. Alright. So now my question has become This is I. So it has become sine. In place of mx we have substituted t, and dx has become 1 by m dt. Now it's a coefficient, it can go out. We have done a property. So what is the integration of sine? I hope you all remember, you have learned the formulas by now. What is the integration of sine? The integration of sine is minus cos. Minus cos. What am I leaving here? Something very important which I am supposed to write it here, which you did in the previous lecture. What? Because we are dealing with indefinite integration, so that is plus c. That is the most important thing in indefinite integration. And why? That you know already. Alright. So minus 1 by m, substitute the original variable. So what is original variable? The value of t, because whatever the variable we started the question with, we have to end with the same variable. Understood? Is it clear, everyone? Alright, let's take more examples so that the concept of substitution becomes more clear. Now my target is I have to substitute, because right now I don't know the substitution of this function, because I told you whatever the formulae we have done, I can substitute only those kind of questions. I can only integrate those kind of questions. Now here the problem is I don't know the integration of 2x into sine x square plus 1. Alright, so I have to substitute something so that this function becomes a simpler one which I can integrate. Alright, अब sine का differentiation I don't have. X square plus 1. X square plus 1. What is differentiation of x square plus 1? X square differentiation is 2x. 1's differentiation is 0. So that means I have the differentiation of x square plus 1. So what I'll do, I'll put x square plus 1 is equals to t. Differentiate 2x. This side will be dx and dt will go that side. Is it clear? Now substitute. 2x dx. 2x dx. What it has become? dt. 2x into dx has become dt, and here sine t. Here it has become sine t. Now we know the differentiation of sine t. What is the differentiation of sine t? Cos t plus c minus cos t plus c. Put the value of t, because we have to come back to the original variable. That's all. Is it clear? Alright, children. Fine. So method of substitution, first of all you have to choose whom to substitute. Your target is to substitute that thing whose differentiation is given to you. That is the basic rule. Is it clear? Alright, fine. Now let's talk about the next question. Now in this question, let's check whose differentiation is given to me. I have tan raised to power 4, I have secant square, I have under root x in the denominator. If I say under root x differentiation, definitely that is 1 by under root x. I have. But it has much more than that. Think about some trigonometric function. Whom shall we put? If I put secant x, what will happen? Think. What shall be the substitution here? I have tan raised to power 4 under root x into secant square under root x upon under the root x upon under the root x. What shall we do? Yes. Shall I do one thing? Tan's differentiation is secant square. Can we do this one thing? If I put tan root x is equals to t. If I put tan root x is equals to t. What happened? Let's see. Differentiation you all know. We know the chain rule. I can differentiate this. With respect to t, first of all, the differentiation of tan. What is the differentiation of tan? Secant square root x. I will not touch this. You have done a complete chapter. We know the chain rule. First of all, I am going to differentiate tan x. The differentiation of tan is secant square. The angle will not change. Into the differentiation of this. Into the differentiation of root x. That will be 1 by 2 under root x dx dt. I hope you know how to do it. It is x raised to power 1 by 2. How do we differentiation? The power comes in front, reduce the power by 1. Power comes in front, reduce the power by 1. So, write it in the proper way. It is secant square root x upon root x. I don't have in the question 2, so this constant I can take any side, that's not a problem. So I'm taking this constant that side. Is it clear? Alright. So now secant square root x upon root x dx. That means this. In place of secant square root x upon root x into dx, what can I write? 2 into dt. 2 into dt. Is it clear? And the value of tan root x is t. So it becomes t raised to power 4. Coefficient, the constant can go out. Now it is a simple question. Increase the power by 1 divided by increase power plus c. Don't forget to put back the original variable. What is my original variable? The value of t, that is tan root x. So I'll put the value of tan root x, tan raised to power 5 root x plus c. Is it clear? 2 by 5 tan raised to power 5 root x plus c. Alright, again children, target is to change the given function into such a function whose integration we can do easily. That's what we are saying, that substitution method is the most important method. Alright, it's the base of integration that we have to keep in mind. Now by now you might be knowing sinus differentiation, cos. I don't have. Tan inverse differentiation. What is tan inverse x differentiation? That we have done. That is 1 upon 1 plus x square. And that's it. It's given here. Alright, so what am I going to do? I'm going to substitute tan inverse x is equals to t. That is 1 upon 1 plus x square dx is equals to dt. Alright, so my question has become I is equals to sine, in place of tan inverse it is t, 1 upon 1 plus x square into dx. 1 upon 1 plus x square into dx has become dt. What is the integration of sine? That is minus cos t plus c. Put back the original variable, that is tan inverse x plus c, and that's my answer. Is it clear? So basic rules remain the same. Try to substitute that function whose differentiation is given to us. Alright, then we will differentiate both sides with respect to the variable which we have chosen. We'll put in the integral, we'll integrate, but in the last step, do not forget to put back the original variable. That's most important thing. Okay, now we are going to do some formulae actually. Like suppose if you remember the list of formulas which we written, we did not do the integration of tan, we did not do the integration of cot, we did not do the integration of secant and cosecant. These trigonometric ratios integration we did not write because we connected those formulas with the differentiation. Alright, fine. So now we are going to drive the integration of these 4 trigonometric ratios, because sine and cos we have already done it. These 4 trigonometric ratios by using method of substitution. Alright, for example, the first one, I have to integrate tan x. I have to integrate tan x. Alright, I have to integrate tan x. Now, tan x can be written as sin x upon cos x. Sin x upon cos x. Now the method of substitution says you can substitute that function whose differentiation is given to me. Alright? And that differentiation has to be with dx. That differentiation has to be with dx, because if you have seen the previous questions, differentiation comes, then dx comes is equals to something into dt. Alright? So now with dx I have sin x, and which is the differentiation of cos. Though the differentiation of cos is minus sine, but I told you constants does not matter. Minus is a sign, it can go out, that does not matter. So what I'm going to substitute here, put cos x is equals to t. Cos x is equals to t. Differentiate both sides with respect to t. Minus sin x dx is equals to dt. I don't have minus here, so I'm going to take this minus that side. Now that's it. So it has become sin x dx is minus dt. So I'm taking this minus out. and it has become 1 by t because cos is t. So it has become 1 by t. Now recall your formula. What is the integration of 1 by t? Everyone knows that. What is the integration of 1 by t? That is log of t plus c. Do not forget this. Is it clear? So put the value of t again. That is cos x. Alright. So that means what we have derived, the integration of tan x is minus log of cos x plus c. There is one more and you have to try first of all the derivation of it. It can be the integration as log of secant x plus c. Integration of tan x can be written as minus log cos x plus c, or we can directly write log secant x plus c. How it has come, that you have to think about it. Is it clear? Right now we are deriving it, but in future in the questions, because it is a formula, you can directly use this formula. You don't have to derive it there. Directly, if integration of tan x is required, you can write down log secant x. Is it clear? The same way we can find out cot. It is cos x upon sin x. So what I'll do, I'll put sin x is equals to t, cos x dx is equals to dt, differentiation both sides with respect to t. So cos x dx is dt and that is 1 by t. Integration of 1 by t is log t plus c. Put the value of t, that is sin x plus c. So we have again one formula, that integration of cot can be its log of sin x plus c. It can be written in the form of cosecant also. Alright, you have to write that. Alright, so now two formulas we have derived, that is integration of tan x is minus log cos x plus c or log secant x plus c, and integration of cot is log sin x plus c or minus log cosecant x plus c. Now let's see the next two trigonometric ratios which I told you. We have integration of sine, we have integration of cos. Now we have done for tan, we have done for cot. The next is integration of secant x dx. Now, in tan I had sine upon cos, differentiation of cos was given. In cot it was cos upon sine, differentiation of sine was given. But here it is a problem. If I write secant as 1 by cos, I do not have a differentiation. So what to substitute? So what I have to do, I have to make a differentiation. See children, integration is such a topic where you have to think a lot. There will be such kind of question where you have to think what to do. Maybe you have to modify the function in such a way so that you can integrate it. Is it clear? Alright. So I don't have, so I am going to make the differentiation. So I am going to multiply and divide it by secant x plus tan x. Multiply and divide by secant x tan x. Alright, that we can do. I am dividing and multiplying. So balance the question. So multiply this inside, secant square x plus secant x tan x upon secant x plus tan x dx. Now check whose differentiation is given to me, because I did this step to create the differentiation. Now see, secant x differentiation is secant square. No, secant x differentiation is secant x into tan x, and tan x differentiation is secant square. So that's given to me. So what I will do, I am going to substitute the denominator, that is secant x plus tan x. Again children, your differentiation should be with dx, because differentiation always comes with dx. So that means you have to be careful about it, how to substitute, what to substitute. So secant x differentiation is secant x tan x. Tan x is secant square x. Dx equals to dt. Alright, now my question has become secant x into tan x plus secant square x into dx has become dt. This has become 1 by t. So my integration is log t plus c. Put the value of t back. That is secant x plus tan x plus c. So one more formula we have derived. That is integration of secant x is log of secant x plus tan x. Alright, the next derivation. So secant x integration is log of secant x plus tan x plus c. Now let's check the next one. Which is left? That is cosecant. Here also I have a same problem. I don't have a differentiation, so I am going to make the differentiation here. I have to make the differentiation here. So, because in cosecant and the cot negative comes, so I am going to multiply and divide by cosecant x minus cot x, cosecant x minus cot x. Alright? So, cosecant square x minus cosecant x into cot x minus cot x. Clear? So again, differentiation of cosecant is minus cosecant into cot, and differentiation of minus cot is cosecant square. I have, so put cosecant x minus cot x is equals to t. Differentiation of cosecant is minus cosecant x into cot x, and differentiation of cot is minus cosecant. So minus is already there. It becomes minus cosecant square x dx is equals to dt. So we got the numerator. Cosecant square x minus cosecant x cot x into dx is dt. So I'll put it equals to, and this is 1 by t, that is log t. Put the value of t, that is cosecant x minus cot x plus c. So we got the last derivation here. So integration of cosecant is log of cosecant x minus cot x plus c. So again children, you all have to remember this, the 4 new formulas, and you have to add this in the list of the formulas where have you written. Is it clear? And everyone is making concept notebooks, so these 4 formulas to be added there now. Which formulas? Integration of tan x, that is, what is integration of tan x? Minus log cos x or log secant x. Integration of cot is log of sin x or minus log cosecant x. Integration of secant x is log of secant x plus tan x. Integration of cosecant x is log of cosecant x minus cot x. You need to add this with the list of the formula which you have done. Okay, let's do some more questions related to substitution method, because I told you this is very important topic. So we have to be thorough with it. I have now integration of sine cube t x into cos square x. Alright. Now target, I have to substitute that function whose differentiation is given to. Sine's differentiation is cos. Cos is minus sine. Minus is not a problem. That means both have a differentiation with there. But what to substitute? Advisable, whenever you have a combination of sine and cos, alright, with some powers, that means this form, always try to put the function with even power. With even power, that makes the question easier. Alright, if you have a function where one is odd, one is even, try to put it which is with the even power. I'll tell you the reason. Here cos has an even power, so I'm going to, my preference is to put cos. Clear? Reason, Can I write this sine cube as sine square into sine? So when I substitute cos, because it has an even power, if I substitute cos, cos differentiation is minus sine, minus will go out. So this sign is adjusted with dx. This sign is adjusted with dx. What am I left with? I am left with the even power of sine, where sine square can be written as 1 minus cos square x. That's the reason. Alright, अगर odd power को अगर मैं sine को put कर दूँ, for example मैंने sine को put किया, तुमने बोला कि नहीं हम तो sine को put करेंगे. Let's put sine. If I put sine, sine's differentiation is cos x dx. तो एक cos square में से चला गया तो दूसरे cos का क्या करोगे? I don't have a formula. Alright. Even powers can be converted into formulas because I have a formula of sine square. I have a formula of cos square. If sine square I know, I can use the same formula for sine raised to power 4 also. For even powers there is no problem. So always better substitute even powers so that out of the odd power one is adjusted with dx and my question becomes little easier. So what I am going to substitute? I am going to substitute cos x is equals to t. Alright. So differentiation minus sin x dx is equals to dt. So put the value t square. I don't have a minus here, so sin x dx minus will go that side with dt. So I'll take minus outside. Sin x dx is dt. So multiply inside. Now it has become a simple question of variables. So that we increase the power by 1 divided by increased power, increase the power by 1 divided by increased power plus c. So put the value back. Alright, this is what you all have to do. Clear? Clear to everyone? Alright. Let's take the next one. Sin x upon sin x plus a. Differentiation of sin is cos x. Differentiation of sin x plus a is cos x plus a. So I don't have a differentiation. So but differentiation of x plus a is what? That is 1. So and my problem is this only. If suppose sometime you are not able to understand whatever is the problem area, now try to substitute that. That also works. Is it clear? Whatever is my problem area, I will try to substitute that. Because sin x here denominator is a problem. So I am going to substitute x plus a is equals to t. So it will be 1 dx is equals to dt. And what will be the value of x? That will be t minus a. Let's see what question becomes. T minus a. It has become sin t. And dx is equals to dt. Can we open this by sin a minus b formula? What is the formula of sin a minus b? Sin a cos b minus cos a sin b. Now I have two terms, denominator I have a single term, so I can split. We can split it. Sin and sin cancel, so I can segregate them. See, in your question there is only one variable, rest everything is a constant. Children, they commit a mistake. Now what is left with me? In this integral I have only cos a dt if I segregate. Alright, then I have sin a, cos upon sin, that is cot t dt. Children, what the mistake we commit? Without thinking, we say, okay, integration of cos, that is sin a. That's wrong. I have only one variable in the question. In integration, we have only one variable with respect to which we are integrating. Here it is x. Now we have converted x into t. So t is the only variable. That means this cos a will be treated as a constant. So it will go out. Sin a will be treated as a constant. It will go out. So what I have? I have integration of 1, that is t. I have to integrate cot. We have done right now. What is the integration of cot? Integration of cot is, yes, integration of cot is log of sin t. Put the value of t back. What is sin? This t is x plus a. Here also x plus a. And that's my answer. So substitution, as it is a very, very important topic, method of integration. So you have to choose wisely which function to be substitute. Base is there, you try to substitute that function whose differentiation is given to me. Alright, we'll just pick up the last question here. Now 1 upon 1 plus tan x. No differentiation. Let's make it. And the questions which you get in maximum number of cases, you have to make the differentiation. It's not things would come in a plate and you are just ready to serve yourself. Alright? You have to think. Then only you will be able to solve the questions. So, I can write tan as sine upon cos. Take LCM. And this cos will go up. Still I don't have a differentiation. Because I need differentiation with dx. So that means I have to think about the differentiation of cos x plus sin x. What is the differentiation of cos x plus sin x? Differentiation of cos is minus sine, differentiation of sin is cos. So I need cos x minus sin x in the numerator to make the differentiation. Ab beta apne aap banana padega. We have to make it. So how am I going to make it? I am going to multiply by 2 and divide by 2. Alright. Can I write this 2 cos x as cos x plus cos x? अब मुझे माइनस साइन चाहिए ना डिफरेंशिएशन के लिए, तो एक और स्टेप, आई एम गोइंग टू ऐड साइन एंड आई एम गोइंग टू सबट्रैक्ट साइन. नो प्रॉब्लम, बैलेंस तो हो गया ना, एडिशन एंड सबट्रैक्शन. Now I split. I am going to do this and this together. और इसके साथ डिनोमिनेटर अलग. This and this together. Fine. This is cancel. That's 1. And this I am going to do by substitution. This part we will do by substitution. Is it clear? What is the integration of 1? What is integration of 1? Integration of 1 is t. So this part is over. Oh, we are integrating with respect to x. So integration of 1 is x, the variable with respect to which we are integrating. Alright, we are left with this part. So now I will substitute here. Put cos x plus sin x is equals to t. Cos x is minus sin x. Sin is cos x. Dx is equals to dt. So cos x minus sin x dx has become dt. And just keep in mind, I have integrated but I have not written c. Suppose if I write c here and while integrating this also I will write c. Constant plus constant is constant only. So I write c only once. So it has become 1 by t dt log t plus c. You can write two constants also because I have already integrated this. Otherwise keep as it is integrated directly here. Alright. Fine. So here also constant, here also constant. Both the constants will give you a constant as answer. Substitute. What is the value? So I got x by 2 plus log cos x plus sin x plus c. These are few examples for substitution method. Now we will try the exercise